C. Standard 12th Maths, Chapter 6, Applications of Vector Algebra, XII 6.4, Sum 7. Before start doing the problem, let me give you a small introduction. See, when the two lines are given in the vector form, vector R is equal to vector A plus S into vector B, and vector R is equal to same vector A some vector C plus T into vector D. Here B and D are parallel vectors. So if these two lines are parallel, see, in the parallel vectors, you take the direction ratios b1i plus b2j plus b3k. Vector D is equal to d1i plus d2j plus d3k. See, you take these ratios b1 by d1 is equal to b2 by d2 is equal to b3 by d3. See, the ratios will be equal if the two lines are parallel. If they are perpendicular, if the two lines are perpendicular, let me take this is B and this is D. Perpendicular. So the corresponding ratios b1 into d1 plus b2 into d2 plus b3 into d3, you will get answer as 0. So let me do the problem now. See, 7&Sum. If the straight line joining the points 2, 1, 4 and a minus 1, 4, minus 1 is parallel to the line joining the points 0, 2, b minus 1 and 5, 3, minus 2. Find the values of a and b. See here, for the first line, the 2 points are given, and we need only the direction ratios. So let me take only the direction ratios, that is of the parallel vector. Vector B is equal to x2 minus x1, a minus 1 minus 2, that is a minus 3. This is the coefficient of I, plus 4 minus 1, 3j, minus 1 minus 4, 5k. This is vector 5k, minus 5k. Take the next parallel vector, the direction ratios. 5 minus 0, 5i. 3 minus 2, 1, 1j. Minus 2 minus b minus 1, minus 2 minus b minus 1, minus minus plus 1, minus 1. So minus b minus 1k. So this is your b1 I, b2j, b3k, d1, d2 coefficients, then d3. So they are parallel, the condition is true, b1 by d1. Since the lines are parallel, given the lines are parallel. So this is the condition, b1 by d1, b2 by d2, b3 by d3 are equal. So b1 is a minus 3 by 5 is equal to b2 is 3. d2 is coefficient of j is 1 here. Then what about b3? b3 is minus 5 by, then d3 is minus b minus 1, minus b minus 1. From this you have to find the a and b value. Take the first two ratios. A minus 3 by 5 is equal to 3 by 1. Cross multiply 1 into a minus 3, 5 3s are 15. So a is equal to 15 plus 3 is equal to 18. 15 plus 3 is equal to 18. Take the next one. 3 by 1 is equal to minus 5 by minus b minus 1. Cross multiply 3 into b minus 3b minus 3 is equal to minus 5. Minus 3b is equal to minus 5 plus 3. Take this 3 to the other side. This is minus 2. So b is equal to minus 3b. So b equal to minus 2 by minus 3. Minus minus cancel 2 by 3. So the answer A is 18 and B is 2 by 3. This is the answer. Next sum. See the 8th sum. If the straight lines x minus 5 by 5m plus 2 is equal to 2 minus y by 5, 1 minus z minus 1 and x equal to 2y plus 1 by 4m, 1 minus z by minus 3 are perpendicular to each other, find the value of m. So we know the condition of the perpendicular, that is b1 into d1 plus b2 into d2 plus b3 d3 is equal to 0. So this condition is satisfied. In that case you find the value of m in both the lines are given here. So first let me take the first line. The line should be in the form x minus x1 by y minus y1, but here 2 minus y. So first you rewrite this. The first term is correct, x minus 5 by 5m plus 2. But here the second one I have to write in y minus y1 form. So take minus outside. So minus y minus 2 divided by 5. Again this is 1 minus z. Take minus outside. Z minus 1 by minus 1. So in this case you will get x minus 5 by 5m plus 2 is equal to y minus 2 by, give minus to the denominator term, minus 5. Again z minus 1 by 1. You collect the parallel vector, vector b. So the direction ratios are 5m plus 2 into I vector minus 5 into j vector plus 1 into k vector. These are the direction ratios of the parallel vector. You take the second line. So x. So just you have x, but the denominator term you can write, is not given, you can take it as 1 is equal to, see this is 2y plus 1. I must have y minus 1 form here. So I take 2 outside so that the coefficient of y becomes 1. So when I take 2 outside, so y plus 1 becomes 1 by 2 divided by 4m. Divided by 4m. This is equal to, and this is given as 1 minus z. Take minus outside. So z minus 1 divided by minus 3. So x by 1 is equal to 2 gets cancelled. So y, it should be minus of, so you can take plus also, see, plus half divided by 2 cancel, 2m is equal to minus cancel z minus 1 by 3. So the next parallel vector d, the direction ratios are 1i plus 2mj plus 3k. So according to the given condition, the lines are perpendicular. The lines are perpendicular. They given. So this condition is satisfied. b1 d1 plus b2 d2 b3 d3 is equal to 0. So b1 is here. So b1 is 5m plus 2. 5m plus 2. d1 is 1 plus b2 is here minus 5. Minus 5 into 2m plus b3 is here 1. So 1 into d3 is here 3 is equal to 0. So 5m plus 2 minus 10m plus 3 is equal to 0. So minus 5m minus 10m minus 5m plus 5 equal to 0. Minus 5m equal to minus 5. So m is equal to minus 5 by minus 5. This is equal to 1. So this is the answer. We are supposed to find the value of m. See the ninth sum. Show that the points 2, 3, 4, minus 1, 4, 5 and 8, 1, 2 are collinear. See, let me name the points. A as 2, 3, 4, B as minus 1, 4, 5, C as 8, 1, 2. What do you mean by collinear? They lie on the same straight line. We have to prove this. We are supposed to prove. We can take the parallel condition. Here also the same parallel condition. B1 by D1 equal to B2 by D2 is equal to B3 by D3. So let me take the first 2 points. If you join these 2 points, you will get a line. You collect only the parallel vectors. That is the direction ratios. So B1. So the direction ratios of AB is equal to x2 minus x1, that is minus 1 minus 2 minus 3, denominator term. The line x, you have x minus x1 by x2 minus x1, same y minus y1 by y2 minus. You collect only the denominator term, that is the direction ratios. Then 4 minus 3 is 1, 5 minus 4 is 1. So that is vector B is equal to minus 3i plus 1j plus k. Then next one, the direction ratios of the line BC. Next line BC here. So 8 minus 1, that is plus 9. You will get 9. Then B is, next is 1 minus 4, that is minus 3. 2 minus 5 also minus 3. Minus 3 minus 3. You take that vector as vector D. 9i minus 3j minus 3k. So you find that B1 by D1, that ratios. Here, this is B1, B2, B3 coefficients. D1, D2, D3. So B1 by D1 minus 3 by 9. That is minus 1 by 3. B2 by D2. B2 by D2. B2 is 1 by minus 3. 1 by minus 3. Then B3 by D3. This is 1 by minus 3. 1 by minus 3. So all the ratios are equal. All the ratios are equal. So in that case the line. So in that case AB is parallel to BC. AB is parallel to BC. See, you have the common point B here. You have the common point B here. So, see, B is here, common point. Therefore, they lie on the same line. That means they are collinear. So, AB, see, they have the, just you write that here B is a common point. B is a common point. Common point. So therefore A, B and C are collinear. The points, these points are collinear. They lie on the same line. Thank you.